Hi everyone, Krishna this side and I welcome you all to this channel. So let's solve this LeetCode question 2785. Sort vowels in a string. Okay, let me read the question. Given 0 index string s, permute s to get new string t. Okay, says that all the consonants remain in their original places. More formally, if there is any index I with 0 less than I less than this s dot length such that s of I is a constant, then t of I is basically equals to s of I. That means like wherever the consonants basically appears, we just have to place them as it is in new string that we are generating. The vowels must be sorted in non-decreasing order of their SK values. More formally, if pair indices I and j with 0 less than I less than j less than this s dot length such that s of I and s of j are vowels, then t of I must not have higher SK value than this t of j. Obviously, what are all different vowels we have? These A, E, I, O, U. These are the vowels we have, right? So they are basically appearing in lower and upper cases. So consonants comprise all the letters that are not vowels. It is pretty much clear that correct. So now, if we look into this example also, here what are all vowels we have? This particular E, then again this O, and lastly this E. So when we compare these characters based on their SK values, right? Obviously, all the uppercase characters that we have, they basically appear first compared with the lowercase letters, correct? So yes, then if we have to sort them based on non-decreasing order, then obviously E will be there as it is at that place. Then after this E, we cannot place this E at here. We have to take this O because O has less ASCII value compared with this particular E. And after that, at this particular O, we can place this E, and lastly, this E will be there as it is. So we just have to sort these characters, the only characters who are vowels, okay? And rest all the characters, the consonants should be there as it is. That is the whole idea. I guess the question is really clear and straightforward. If we look into the constant, this yes dot length is actually around 10 to the power of 5, and yes consists of all the uh, letters in alphabet like upper and lower cases, okay? So question is really straightforward. We can write it in various ways. So let me connect the screen. I'll explain you a simple approach. Then we will discuss about how we can optimize it, and I'll write down the optimized solution as well. Okay. Let us suppose this is the string that is been given to us, and when we compare the all vowels that we have, right? So this A's ASCII value is less than this E, and this I is having higher than this one, then O, then U. In this way, the characters basically appear in ASCII, right? So we just have to maintain this order, okay, while generating this particular string. So any character basically appears in this one. Those are vowels. So their order should be in this way. So here, if we check all the vowels that are available in this particular string, those are basically this particular E, okay, this particular E, then here E, I, and A. These are only vowels that we have, right? And rest are all consonants. So here, let me take out this E, then I, then A. So if we sort them based on their SK values, so obviously A will be appearing first, then here E basically appears, then I appears, then lastly E appears. Okay, so this particular order is something what we have to maintain while generating this string. So when we try to generate strings again, here L will be there as it is because it is a constant, so we have to maintain its position. Now here I cannot keep this E, okay, because we have these characters. So based on these characters, I have to generate a string. So first character instead of E, we have to pick from here, that is A. Next, T will be there as it is. Next, M will be there as it is. So here again E is something what we have. So we use this A, we have to use this E. So E will be there. Next, I is there, I will be there as it is. N will be there. Then instead of this A, we have to pick this E. Okay, and lastly S will be there. So this is how we have to generate the string. So while generating it only, we got to know that like how we can do it, right? So what we can do is basically a simple approach if we think about it, right? So what we will do is we will collect all the vowels that are available in this one, okay, in given string. What are all different vowels that are there, those we can consider in string builder or array list or arrays. In any form we can consider, we can pick all of these vowels. Once we pick them, we can easily sort those the information. Once we have sorted that, we can consider a pointer right over here, and at any point in time in this particular given string, if we notice any vowels, so at that vowel what we can do is we will pull out from here and we will place it, and pointer will point next, point to this particular next character. Okay, that is the whole idea. So once we place it, we move ahead at any point in time. Again, if we notice any vowel, we will pick it from here. So for this particular approach, if we discuss by considering all the vowels in another array list or anything, it will take big O of n in worst cases if we see that all these characters are vowels. So yes, space is going to be big O of n, and again while sorting this information, it will take n log n. Okay, so n log n plus, again while generating this particular string, it will take big O of n. So overall the complexity is going to be, space is going to be big O of n, and time is sorry, this time particular is going to be n log n. Okay, so that is the time complexity that we can get it with this one, and it is completely fine if we try to write down this approach as well. But let us suppose if interviewer asks you like just optimize it, don't sort this information, and in place can you perform the operation, right? That if that is the question, you get it further. So what you can do is, see, the idea is pretty much simple. Since this string is basically generated based on all the lower and uppercase characters, right? Lower and uppercase characters. What we can do is we can use frequency array. So because in frequency array, these lowercase characters are 26, uppercase characters are 26. So we can maintain two different frequency arrays. Okay, first frequency array will be, let us suppose int upper, which is having 26 characters. Okay, it is having 26 characters, and lower array is also there, which is having 26 characters. Idea is pretty much straightforward again. So if we notice any lowercase characters who are who are basically vowels, so they will get appear in these lowercase characters. Okay, so let us suppose here e character appeared multiple times. Let us suppose 3 times e character appear in a given string. So in this lowercase character, what we can do is lower of this e character that we have saw, right? A minus a. When we do it, this basically take us to 0th index. Okay. If we have b character, e character appeared, a minus e, sorry, e something, e minus a. So that is the character if we notice e minus a. So we can take it to the eth index. Okay. So eth index is like e minus a when we do it, right? So e is basically, let us suppose whenever we perform this operation, whatever the difference that we get it, e minus a, their ASCII values difference. That is something what we get it right over here. So, I don't remember the ASCII value, but generally in between them, five difference is there, right? Like let us suppose E is 5, A is 1. So when we subtract them, the 4 is the answer that we get it. So at fourth index, this E character will appear. Its frequency is something what I'm talking about. Okay. So this way we will keep on collecting their frequencies. So in uppercase character, all the vowels who are appearing in this particular string, their frequency is something what we are maintaining right over here. And lowercase characters frequency is something what we are maintaining right over here. So how this basically looks like? So at 0th index in uppercase character, let us suppose A is the character that is something appeared 3 times. So in this frequency array, it basically looks like 3. At first index, basically here we don't see anything. Second index, we don't see anything because only A, E, I, O, U. These are the characters whose frequencies possibly appear in this particular one. Okay, because in this particular one, we are only considering all the uppercase vowel characters. Okay, those frequencies something what we are maintaining right over here. In lowercase, again, all the vowels basically appeared in this particular string who are lowercase characters. Those characters frequencies on something what we are maintaining right over in the lowercase characters. Okay, now when you see that here in this particular frequency array, okay, this is basically 26 of size, this is basically 26 of size, AE, here these are small characters, okay, O and U. So all this frequency also we got it in this lowercase array basically. So what we can do is again same thing, we can start traversing through the string, this particular string, whatever the string that we have. Correct. And at any point in time, if we notice any vowels is something what we saw. Okay, uppercase vowel if we saw, so basically we will start iterating from this uppercase characters. Okay, and from here we will keep on starting at any point in time. If this character frequency is something what it is not equals to 0, we will consider that index plus this a. When we do that, again it will appear a. So a character is something what basically appearing, that is something what it basically says. So that character is something what we will place while building the string. Okay, at any point in time, if we notice here any type of vowel at any point in time, so at that point in time we will start iterating from uppercase. From uppercase we will start iterating. Okay, once we are done with this uppercase, once all these frequencies are basically counted and considered, we will shift our focus to the lowercase, and from this lowercase all the characters, because this data is basically already in sorted order. Okay, in this frequency array, data is already in sorted order, so we don't have to worry about it, and we are not even utilizing a lot of space, because here we are just using 26 size of array, which is basically constant, right? So again, we can, once this particular frequency array is done, we will start looking into this lowercase at any point in time. If again we notice any vowels appearing in this particular given string, we will get check that in the lowercase if that particular index is basically equals to 0 or not. If not 0, then that index is something what we will consider, and that index plus a, that is something what we will append it. Once we use that, the frequency is something what we have to reduce. Okay, I guess this particular approach is clear. See, even if we are struggling with this particular one, what we can do is, once we build this one, whatever the characters basically appeared in this uppercase or lowercase array, those frequency, let us suppose a basically appeared, if its frequency is higher, what we can do is we can simply convert it into the string builder, and in that string builder we can keep on appending that particular character. Okay, string builder, let us suppose a character appear 3 times, so we will keep on counting. If frequency is higher, so 0 my sorry, this a, whatever this index, basically index plus a is something what we have to do, index plus a. This way it will get converted again back to a. If index is basically at this e, so that index is basically 4 plus a, it is going to be e. Okay, this way we can convert the characters. So 4 plus a, it is going to be e. So these are the characters. We will keep on adding it into the string builder. Once we traverse to this uppercase, we will start traversing into this lowercase array, and we will keep on generate the string. So in the string builder, again, the data is basically in a sorted order, and that data is basically in place. So this is something what we again built. Once we build it, again, the previous operation that we discussed, that is something what we can perform it. Okay, the question is clear. I think we just have to write down the code now. Let me write down the code, the approaches that I have discussed. The last approach that I have discussed, that is something what I'll try to consider, and I'll write down that code. Okay, so the first thing is we have to create here frequency array, int upper. Okay, new int 26, int lower, new int 26. You may say that like we should have used hash map, because we have only 5 characters of this one, 5 characters of this one, only those characters we are considering, right? But still, hash map internally takes a lot of computation compared with this array, and this basically speeds up more compared with the hash map. So it is better to use array at any point in time if we are considering lower or uppercase characters, these kind of scenarios. Okay, so here what I can do is I can consider the character from this s dot to char array, and we can check that. We can check, we have multiple functions that are available, but right now I'll just put here simple if condition. If ch equals to a, ch equals to, okay, these are the two conditions we have, right? So if all these vowels are basically small I mean lowercase characters, so we will update them, their frequency, in the lowercase character. So here what we can do is whatever this character minus a, if we do that, we will get index. So that particular index is something what we are updating. That means its frequency is something what we are updating. Going ahead here, these are uppercase characters. So in the uppercase, we will update here. We will get the index, and that is something what we are updating. Okay, so if ch is basically equals to a, so 0th index will get updated. Its frequency is something what we are updating. Okay, if e is something what we got it, e minus a is basically a 4, so 4th index is basically we are updating it. Okay, because that particular e character appeared that many times, that is something what we get it. Once we updated this character's frequency, we can simply build a string builder. That is something the easiest way we can do it. We can avoid this particular step as well, but this is fine. Just to explain you, I am writing this way. So string builder sb equals to new string builder. Now we will start traversing from this uppercase first. Int I equals 0, I less than 26, I plus plus. We check that we have to use while loop right here. So at that point in time, if any particular index frequency is greater than 0, right? So we have to keep on collecting that character, and we have to dump it into this string builder sb. So we'll check that if this whatever the I index that we have, right? So while this upper of this I If its frequency is greater than 0, we have to reduce this frequency and we have to append that character into this SB. SB dot append this whatever the index that we have plus A. Okay, this way we can again get the character. Okay, previously we subtracted that, now we are adding plus A from this uppercase so that that character is something what we can get it back. So let me just typecast it. And once we are done this, let me run another for loop and collect all the lowercase characters, because this frequency, whatever the frequencies that are appearing, they are basically in sorted order. Okay, so that way we can utilize it. So let me paste it as it is, and here let me consider this lower of this I if it is greater, and then we are doing this, and here instead of this A we are considering the. Now the string builder is ready. In this string builder all the data is basically in a sorted order, and this particular operation we done it in big of n. Okay, so if n vowels that are there, so obviously n storage is what we have considered right over here at this point in time, and these are basically constant, so nothing much. Again, this big of n is what we are considering. So yeah, now we have to generate the answer, right? So let me generate the answer. Answer equals new string. Okay, so let's again go through this string that we have. Yes, dot to array, and we will simply maintain here a pointer I equals to 0. Let me consider that, so that we can check at any point in time if any vowel or consonant is something that we saw. Let me copy this particular if statement, if this one as well as this particular thing. Okay, so here I know there are multiple functions. Okay, so yeah, right now I just prefer writing this way. So once we get all these vowels or consonant, if at any point in time in this particular string ch is basically equals to AE or all these characters, then we can get that from this whatever the string builder that we generated, right? From there, sb dot char at I, and this I is something what we can update. Else, whatever the character consonant character that we have, that is something what we will append it. Append ch as it is. Yeah, this way we can generate the answer. Now and then just return this answer dot to string, because it is expecting in a form of string. Okay, this way we can write down this code. Let me try to see, let me run it and see if it is working fine or not. There is an error, line number 21. sb dot append ch. Okay, I have to close this one. Here also. Any other errors? I think those are the errors. Let's see if it is working fine or not. Yeah, it is getting accepted. Let me try to submit this. Okay, it is getting accepted. I hope you get this idea. So we are just using constant of big of n time complexity, and big of n is the space that we are using it. Okay, I hope you get this idea. If so, make sure to like this video. Thank you for watching this one. Bye bye.